Let us discuss reinforcement. Here we will find the four type of reinforcement it is talking about. One is the mild steel, second is that high strength steel, third one is hard drawn steel, wire fabric, and fourth one is the structural steel. Here you will find that mild steel and high strength reform bar are most commonly used for our structural purpose. Now C and D will try to find what is the hard drawn steel wire fabric means and what is the structural steel means. Let us see this code 1566 and then 2062. Here the IS 1566, it is saying that specification for hard drawn steel wire fabric for concrete reinforcement. So this is for concrete reinforcement and it is hard drawn steel fiber wire fabric. So basically it is talking about fabricated steel wire mesh. It can be a square shape or it can be another shape. So here there are two type of things this code is recommending. One is square mesh, another is that oblong mesh. So square mesh is square shape and oblong mesh which is not square in nature. It can be leaf like thing, it can be any other shape which deviate from the square mesh, that we call the oblong mesh. So here IS code is recommending these two type of fabricated mesh for steel reinforcement for structural purpose. Now we will try to see about the 2062. 2062 is for hot rolled medium and high strength structural steel. Okay, so here you see it is talking about structural steel, not about the reinforcement bar or rod. It is talking about steel plate, strip, shape, section. So it is talking about C section, angle section, T section, beam section, channel section, or any other shape. Okay, which directly we can use for structural purpose. Okay, so this code, so IS 456 is recommending four type of structural steel for the reinforced concrete design. Now here we will try to find what are the recommendations for mild steel and high strength bar. Now here you just see is talking about the modulus of elasticity of steel. Here you can see that modulus of elasticity of the steel is talking about for mild steel as well as for HYSD bar. For both the bar, the modulus of elasticity of reinforcement is 200 GPa, or it is writing about 200 kN per millimeter square. So if you convert to the GPa, it will be 200 GPa, or you can say 2 into 10 to the power 9 Pascal. Second one is talking about the yield strength. Yield strength, it is saying that characteristic yield strength of different steel shall be assumed as minimum yield stress or 0.2% proof stress specified in the relevant Indian standard. 0.2% proof stress specified in the relevant I standard. So it is talking about the yield strength should be considered minimum of yield stress or 0.2% proof stress. Now we will discuss what is the yield stress and what is the proof stress. Now see here, for mild steel it is very easy for us to get the yield value. Here you can see in the second graph that point B is the yield point. Okay, so here it is easy in the sense after yield there will be sudden jump. In the stress strain graph, if you plot, you can have the definite point. So it is easy for us to get the yield point. Here if you see the second graph, here this graph is for your mild steel and first graph is for in general steel. In general means here you can find we have plotted three grade of steel: Fe250, Fe415 and 500. Fe250 and mild steel are the same graph. Okay, mild steel have that capacity of yield value of 250 MPa. So for this reason, we are designating it as a Fe250, and for higher grade steel we designate as Fe415 or 500. So here we will try to see what is the difference in the yield stress. Now if you consider mild steel and if you plot the stress strain data of a tension test, then you will get this type of graph for mild steel. So here initial portion is straight up to a point, you will say this is proportional limit. So up to this point stress strain is proportional, and from the slope you can find the your Young modulus. Now if you go beyond the proportional limit, you will get this point B. B is your yield point. Now see here, at this point B there is a sudden jump in the stress. Okay, so now since there is a sudden jump in the stress, it is very easy for us to identify the point B. So it is very easy for us to identify the yield value for mild steel. Now if you consider the Fe415 and Fe500, which is basically you can say higher grade steel, in that case you can see this graph is continuous in nature. This graph is continuous in nature, so it is very difficult to get the definite yield point. In that case, what IS code is recommending? IS code is saying that you have to take the 0.2% proof stress. Now what is the 0.2% proof stress? It is saying that at the 0.2% of strain, you have to draw a straight line which is parallel to the initial portion of the stress strain graph. So what we have to do? We have to first pinpoint what is 0.2% strain, or you can say 0.002 strain, and you have to draw a straight line which is parallel to the initial portion of the graph. Now what you have to do? Now you have to identify at which point it is intersecting. So see here, for Fe415 it is intersecting at this point, and for Fe500 it is intersecting at this point. Now here see, for this point it is nearly 400. For Fe415 that yield stress is coming nearly 400, and for 500 grade steel that yield stress is coming nearly 500. So here this stress is basically 2% proof stress. So IS code is recommending that you have to consider the minimum value of these two. Of these two is basically either you have to consider the yield stress if you are able to find directly the yield stress, or you have to consider the 0.2%. Okay. Now for Fe415 and Fe500 or higher grade steel, since we don't have yield point, definite yield point, in that case we have to consider 0.2% proof stress. For mild steel, it is saying we can directly consider the yield value. IS code is recommending here, it is saying that you have to either consider the yield stress or 0.2% proof stress, whichever is minimum. Okay, so these are the things are there for the steel reinforcement.
Till now, we have discussed various IS code recommendation on the aggregate water admixture reinforcement. Let us discuss about the concrete. Here you see it is saying that table 2 and the table 5, an important table for the concrete, is saying that the concrete shall be graded as per table 2. Okay. It is saying that grade of concrete should be designated as per table 2. So we will see what table 2 is talking about. So this is the table 2, is the grade of the concrete. Here you find the three grades of the concrete. One is the ordinary grade, another is the standard concrete, and the high strength concrete. Ordinary, standard, and high strength. Here it is talking about three grades of concrete: ordinary, standard, and the high strength. Here you will see that the designation of the grade of the concrete. For M20 grade, your characteristic strength or the characteristic composite strength of the concrete is 20, and we designate as M20. M is here for the mix. So basically it is saying that we will designate as per the strength. M50 is the 50 grade concrete, and its characteristic composite strength is 50. So it is saying that if you test a cube at 150 mm size at 28 days, then the strength would be mm, and we designate it as a M50. M is for mix. Okay, so this is the things is there in the grade of the concrete in the table 2. This is the things are there in the table 2 grade of concrete. So here we will find three grade of concrete: ordinary, standard, and high strength grade. And that ordinary concrete limit is up to 20. Standard concrete limit is up to 55. And high strength is saying talking about the 80. Okay. The high strength basically start from 60 MPa to 80 MPa. Now here we will see what are the other recommendation that IS code has specified. It's saying that minimum grade of concrete for plain and reinforced concrete shall be as per table 5. Okay. Here it is saying that minimum grade of concrete should be as per table 5. Another thing is saying concrete of the grade lower than those given table 5 may be used for plain concrete construction, lean concrete, simple foundation, foundation for wall. What is saying? It is saying that whatever the whatever the specified strength is given there, whatever the specified recommendation is given there, you can use lower value also, but only for those which are not structural concrete. Structural concrete, okay, it is saying that for plain construction, plain concrete, simple foundation, foundation for masonry wall, which are very simple use in that case, if you use the lower grade, okay, but for most of the cases, you should follow the recommendation given in the table 5. So we'll see what is there in the table 5. Here you will see in the table 5 talking about the minimum cement content, maximum water cement ratio, minimum grade of concrete, different exposure conditions with normal aggregate size of 20 mm nominal maximum size. There is two type of concrete. One is a plain concrete, another is your reinforced concrete. Okay. Now that minimum grade of concrete here, minimum grade of concrete is recommended based on the exposure condition. If the exposure condition is very mild, in that there is no grade of concrete specified. For moderate, it started with the 15 grade concrete, which is a plain concrete. Now again, for the mild case, if we consider reinforced concrete, then minimum grade of concrete is 20. Okay. Now for moderate case, minimum grade for plain concrete is talking about 15, but if it is reinforced concrete is 25. So here you can see for plain concrete, minimum grade of concrete is somehow lower in comparison to the reinforced concrete. Now if you consider extreme conditions, in that case you should use M40 grade concrete if it is a reinforced concrete. Okay. Now here you just see that minimum cement content per meter cube. It's saying that this column 2 is talking about the minimum cement content per meter cube in kg. So if 1 meter cube concrete, in that case, if you are using minimum grade, if you are using mild, if you are considering the mild steel exposure, so there you use 220 kg cement. Okay. Similarly, if it is mild conditions but it is reinforced concrete, then you should use 300 kg per meter cube of the concrete. Now for here you see this cement content is basically gradually increasing in the range of 20-20 only, except in one case this 20 220 240, again you see 260 280, here also 300 300 320 340 360. So here you do, again we have to devise one mechanism to remember it. Now here you will see the water cement ratio. Now here decreasing, cement content increasing, cement content is increasing, but water cement ratio is decreasing depending on the grade of concrete. Here you can see depending on the grade of higher grade of concrete, water cement is low. You see higher grade of concrete, water cement ratio is low. Okay. So these are the things that are there in the table 5. Now you will see what are the other recommendations that I space it. What are the other recommendations IS code is specified for the concrete. So here table 2 and table 5 we discussed. So here it is saying that if, apart from our structural concrete, okay, you can use for the structural concrete actually you should use the you should use as per the table 5. For structural purpose you should use the concrete as per table 5, but you can use lower grade of concrete for few cases. I also recommended 4-5 cases. Here it is a link concrete, simple foundation of masonry wall. For the simple other construction or temporary construction, you can use lower grade of concrete. Okay, but for structural purpose, you should use the concrete as per table 5, where it mentioned for reinforced concrete minimum M20 grade concrete should be used. Okay, you can see M20 grade is minimum for reinforced concrete. Plain concrete, it's talking about M15 grade concrete. Now we see what the properties are there for the concrete. It's saying that we should check the strength at 28 days, and it is saying that there is normally a gain of strength between 28 days. So concrete is to gain strength after 20 days also, but we should test it in at 28 days, and you should design as per the strength of 28 days. Here you see it is talking about the tensile strength of the concrete. Now, I already discussed many times that concrete very poor in tension, it cannot carry tensile load or tensile stress. It will break very easily because while applying tensile stress, the deformation is so low that it cannot absorb it and there will be sudden failure. Now, we will see here what are the recommendations given for tensile stress on the concrete. Now, here for the tensile stress on concrete, we cannot have direct tensile test. For compression test, we can make a cube or we can make a cylinder and we can test it under compression and we will get some data. But in case of tensile strength, we cannot have direct tensile test. We cannot have direct tensile test. So, what we do, we have to go for indirect testing. Here it is talking about flexural test and the splitting tensile strength test. Okay, here is talking about flexural test or splitting tensile strength test for the tensile strength of concrete. Okay, so it is saying that you can do that testing and you can check what is the strength, but again you have to check the reliability of the data, how much data the reliable is. Okay, there is a chance that the data you get from the textural test or 2-point bending test of a prism, the data may vary up to 50 to 100%. Okay, so suppose you are getting one and at the end that it may be 2. Okay, so data may vary. You have to check the reliability of the data for the tensile strength to obtain during conducting flexural test or splitting tensile strength test. Whatever the data you are getting by conducting flexural test or splitting tensile strength test, whatever the data you are getting by conducting flexural test or splitting tensile strength test, okay, you have to check that data. You have to check the reliability of the data. Now, what IS code also recommending here, it is saying that if you don't have that facility, if you don't have the facility, then you also can get the flexural strength from the compression test or from the compressive strength of the concrete. It is saying that flexural strength of the concrete should be 0.7 root under FCK. So this is also an indirect way and it is recommended by IS code, so you can directly use this value for the tensile strength of the concrete, that is 0.7 into root under FCK. Now here you will see what IS code is talking about, that modulus of elasticity of concrete. Now since the modulus of elasticity normally we measure in the linear part of the stress strain graph. So we assume the initial portion is linear and we draw a tangent there, and from there measure the slope, and the slope is the modulus of elasticity of that material. Now for concrete, the graph is parabolic in nature. From the beginning, almost from the beginning, concrete is to say non-linear nature. Or that you can say the stress strain behavior is non-linear nature. So very difficult to get the tangent. Okay. So IS code is recommending that you can draw a tangent in the initial zone. Okay, and that basically you can consider the initial tangent modulus. Okay, that value you can use, or you can use the value of 5000 root under FCK. Okay, the initial tangent modulus is also known as a static modulus of plasticity. Okay, so either you draw a tangent at the initial portion of the concrete, initial portion of the stress strain graph of the concrete, and from there you can get the slope, and prove the slope will be your initial tangent modulus, or static tangent modulus, or static modulus. Okay, or static modulus of plasticity, or you can say the short term static modulus of elasticity. Okay, you can draw a tangent in the initial zone, that data you can use, or you can use the value of 5% root under FCK. That value are known as a short term static modulus, or you can say initial tangent modulus. Here also you can see we are calculating it indirect way. Okay. And IS code also is recommending we are calculating it indirect way, and IS code also is recommending this. Okay, they are recommending this one because there is some physical difficulty, because there is some practical difficulty, there is some difficulty to get the reliable data from the stress strain graph. Okay, so IS code is recommending that if you have compressive strain, then you can calculate the static modulus. You also can calculate the flexural strain or tensile stress data for the concrete. So one is the 5 root under FCK, another is 0.7 root FCK.
Let us discuss about the sinkage and the creep. Shrinkage is basically loss in volume due to the loss of water, or you can say sinkage or contraction in volume due to the loss of water. So now sinkage can be many types. One is your plastic sinkage, autogenous sinkage, drying sinkage, and there can be carbonation sinkage. So plastic sinkage is basically which occur in the plastic stage in the concrete. And autogenous shrinkage is basically when you add water to the cement react with the water. So we just see the water react with the cement and producing CaCl. So there is a loss of water, and due to that loss of water, there is a contraction of volume. Plastic shrinkage, basically in the plastic stage, there is evaporation loss due to the air, due to the temperatures. That is called your plastic shrinkage. So now autogenous shrinkage, plastic shrinkage, drying shrinkage. In the drying stage of the concrete also, there is a loss of water from the pores of the concrete or pores of the CSH gel. That due to the loss also, due to that loss also, there is a shrinkage. So there can be autogenous shrinkage, there can be plastic shrinkage, there can be drying shrinkage, there can be carbonation shrinkage. Carbonation shrinkage occur when concrete react with the carbon dioxide present in the environment. So what IS code is recommending, it is saying that total shrinkage strength shall be taken as 0.003. Okay, so there can be different types of shrinkage. Few shrinkage are instantaneous. If you add water and shrinkage start from that time. Some are time taking, such as your drying shrinkage, such as your carbonation shrinkage, plastic shrinkage also. So it is saying if you consider total shrinkage, that value should be taken as 0.003. And creep is another phenomena in which there is a deformation at the constant load. So creep is that deformation at the constant load. Okay, and it is saying that to identify what is the effect of creep, in that case you have to consider a creep coefficient. Okay, and creep coefficient is the ratio of ultimate creep strain and the elastic strain at the stage of loading. Okay, now how the creep coefficient is changing is that you just see as the date increases 7 days, 20 days, 1 year, that creep coefficient is decreasing. Okay, So here basically it is saying that you have to use this creep coefficient for design purpose. Okay, and this creep coefficient value changes depending on the time duration you are considering on the concrete. Now there can be thermal expansion also. So now different component present in the concrete expand at different rate. Okay. So this quartzite, sandstone, granite, basalt, limestone. So what type of aggregate you are using? Okay. So different aggregate have different thermal coefficient. So IS 456 has specified this thermal coefficient. Okay. You can remember these values. Let us discuss the workability of the concrete. Now see, there is two term workability and the consistency. Workability of the concrete is basically how much workable it is. Okay, some dry concrete also may be workable for one purpose, but in some cases more water is required. Wet concrete may be workable. Okay, so if you consider that road construction, in that case, there's little bit dry mix concrete may be workable, but for structural concrete we need little bit more water. Okay, so workability and the consistency is different things. The consistency is the ability of the concrete to flow. Okay, we normally measure workability since we are considering concrete for structural design. Okay, so here adding water is basically indicate that more workable. But again, you should take proper precaution because adding more water lead to less strength. Be proper water cement ratio. So workability, you just see one qualitative term that we measure. You can say low workable, high workable. Okay, but we cannot measure directly. We just say this is work measuring. We used to measure by through the slump test. Okay, so workability is a qualitative term. So we used to say high workable, low workable, moderately workable. Okay, and we measure through the slump test. Okay, so here you just see for the blinding concrete, shallow section, low workable concrete is sufficient. For mass concrete, lightly reinforced concrete, low workable concrete, we use slump value is 25 to 75 mm. Okay, is permissible. All heavy reinforced concrete, medium workability should be there. Okay. Now, if you considering that pumpable concrete or pump concrete, then your workability should be high. Okay, the workability in the range of, or you can say that slump value in the range of 100 to 150 mm. So depending on the what type of construction you are doing, depending on that, there should be your different quality of workability. Okay, different grade of workability is required. Okay, depending upon the work, depending on the reinforcement, whether lightly reinforced or heavily reinforced, whether it is pavement concrete, whether it is concrete for structural purpose, different quality or different workability is required. Okay, so workability basically is on term we use to see how much workable the concrete is, and consistency is the ability of the water to flow. Okay, workability is one qualitative term, and consistency you can measure. So this is the IS code recommendations for your workability of the concrete. Here we'll discuss different exposure conditions. Okay, so IS code specify different exposure conditions such as mild, moderate, severe, very severe, and extreme. Total 5 exposure condition is there. So mild exposure condition is talking about the concrete surface protected against the weather and aggressive conditions, except those situated in coastal area. So basically, it is talking about if the concrete is not in the coastal region, not near the sea area. Okay, in that case, we can consider the exposure condition is mild. In normal cases, it will be mild conditions. Now, moderate condition is that on the concrete surface sheltered from the severe rain and freezing and wet conditions. It is talking about that if the concrete surface is subjected to rain, okay, in that case we have to consider your moderate exposure conditions. So moderate exposure conditions when it is under the severe rain or concrete is subjected to rain continuously underwater. Okay, concrete in contact with or buried under the non-aggressive soil. When the soil is not aggressive, okay, there is not much chemical compound present in the soil. Okay, in that soil, if you are casting the concrete, then you have to consider the moderate exposure conditions. Now, severe conditions when the concrete is exposed to severe rainwater, alternate wetting and drying season, occasional freezing, and severe condensation. So, when the concrete is subjected to this excessive rain, alternate drying and wet conditions, freezing and thawing, okay, in that case you have to consider the severe exposure conditions. Now, when you're considering your very severe, in that case, actually if the concrete is subjected to seawater, corrosive fumes, or severe freezing conditions there, in that case you have to consider very severe. An extreme condition is there when the concrete is in contact or buried in aggressive subsoil or groundwater. When the very much chemical is present there, much chemical is present there, in that case you have to consider your concrete is under extreme exposure conditions. Okay, when the concrete surface in the tidal zone, in that case also you have to consider the extreme exposure conditions. Okay.